be successful in understanding logarithm, this is the skill that you need to master: how to express exponentials to logarithms and logarithms to exponentials. Because by principle, if you cannot solve exponentials by itself, you need to use logarithm. Okay? Conversely, if you cannot solve logarithm by itself, you need to use exponentials. So what is the meaning of logarithm? Logarithm simply means exponent. So therefore, I always say this: the answer in logarithm is an exponent. So if you have y equals logarithm of x base b, it means your y is your exponent. Okay? And you can express this as b raised to y equals x. So you see your base is b. Anyway, it's written under, so it must be the base. So the base is b, the exponent is y, and the power is x. So we say that this is our power. Okay, usually they would think that the power is the exponent. No, the power is the value. When you raise an exponent, when you raise a base to an exponent, the value is the power, because that's the value of the exponential expression. So therefore, it's just fitting to say that's really the power. Y is your superscript, or we also call it the exponent. We also call it the logarithm. So it has really three names: exponent, superscript, and also logarithm. Okay, that's why we say subscript, because it's written under. So if it's written above, that's superscript, like Superman. Okay, and of course b is our base. So as you can see, if you're going to express it conversely from logarithm to exponent, so you have logarithm of x base b equals y. Your y is your logarithm, so therefore this is your exponent. And of course, your base is b, so that's b raised to y is equal to x, and x is our power. So making this really easy if you really know the vocabulary, because math is vocabulary by itself. You have to understand the vocabulary in order for you to uh, understand even the most difficult problem. If you know your vocabulary, you're not going to have a problem with it. So this is logarithm of 81 base 3 equals 4. So you should also know how to say it. You can also say logarithm of base 3 of 81 equals 4, or logarithm of 81 base 3 equals 4. So you see the subscript is 3, so it's gonna be written under, and 4 is your logarithm. It means 4 is our exponent, so that you will not get lost. Remember, the answer is the exponent. So therefore, this is 3 raised to 4 equals 81. Okay? This one, our base is 7. Our exponent is 1. And it's equal to 7. Okay? This one, our base is 1/3 or 1/2. And our exponent is 3 is equal to 1/8. It always, it's like it's going around. As you can see the direction here, if you change the logarithm to exponential, it goes in a counterclockwise direction from the base to the exponent to the superscript. So the power. So therefore, from the base, 3 to the exponent, and then 1. So 3 raised to 0 equals 1. Going in a counterclockwise direction, starting from the base. Okay, now, let's do the converse, or the opposite of what we are doing. So how do we express it as logarithm? So these are common mistakes of students. The reason why you're converting it into logarithm is because you want to put logarithm in the equation. So the first step is to write the logarithm. Okay, from the equation, you need to know what your base is. Of course, base is written under. And of course, you need to know the concept of the logarithm. The concept of the logarithm means the exponent. The exponent here is 2. So therefore, the equation is equal to 2. And your base is 8. It's going to be written like smaller than the usual. And this is your 64, which is your power. Okay, so making this as logarithm of 1000 base 10 is equal to 3. Now, in logarithm, if your base is 10, we call it common logarithm. You actually don't need to write it. It's understood to be common logarithm when the base is not written. So you have logarithm of 1000 equals 3. that means your base is 10, and you actually don't need to write it. It's like uh, in anything other than algebra, if you don't see it, it's 1. In logarithm, if you don't see it, it's 10. In radicals, if you don't see it, it's 2. Okay, same thing also with logarithms. We have such principle as that. All right, so since I don't have space, I'll go to number 4. So to write logarithm, okay, because you're trying to express it in logarithm, it's just fitting to put logarithm. Our base is 3. Okay, and of course, our exponent is negative 4. So the logarithm should be equal to negative 4 because the logarithm and negative 4 are just the same. And our power is 1 over 81. Another concept of logarithm that's not really mentioned here is the, the constant e, or let's say I have e raised to x equals y. This is an approximate value equal to 2.72. We use it with continuous compounding because there is a principle that you remember banks are giving us a rate of interest 1 plus r according to principle. As time goes by, let's say you're not depositing, you're not withdrawing, as time goes by, in 100 or 1,000 years, that 1 plus r will approach the value of e. That is why it's a certain constant value aside from pi, which is 3.14. In natural logarithm, it means continuous compounding. When you don't even know that it's there, like there's a dirt in a certain shirt like this, and you just let it be, it's going to uh, compound by itself in the near future without you even noticing it. And in math, that value is equivalent to E, which is approximately equal to 2.72. So we write it as ln, and it's understood that this is base E, and it's, remember the exponent is x, so therefore this is equal to x. And you are trying to find the natural logarithm of y. So if you have e raised to 2x plus 5 is equal to 4, right, ln? That means logarithm of base E, and 4, and our exponent is 2x plus 5 because this is the exponent. It's also the same as writing it this way, but it's always fitting to write it as natural logarithm of 4 is equal to 2x plus 5.